Good morning or good afternoon, ma'am. We as a group noticed that reading is arguably one of the most important skill set, yet often overlooked by the people. So we as a group created a program that will calculate your average reading speed.
And we present to you the Hermes Reading Speed Analyzer. The program, apart from its main use of being a reading speed analyzer, possesses many features that focuses on the user experience, such as options that will allow a user to change certain parts of the program for a more user-tailored experience. With this in mind, the program also has a built-in online article scraper, which allows the user to use online resources as their text to be read. After you finish a text or article, the program displays your words per minute. It then shows how well you have done based on your scores treated on different treatments. These are stored internally in the statistics option for later perusal. Tips on how to improve are also shown in order to help the user improve and be a better reader.
Rather than relying on manual character inputs, we've streamlined navigation using arrow keys. This enhancement is done by creating a class with a variable named options and active options. The latter dictates the index of the selected option. Let's say the value of the option variable is this. This is a 3x2 matrix identified with its corresponding columns. For instance, if our active options are 0, 0, and 1, 2, this reflects that the user has selected scenes A1 and B3 respectively. To visually represent the dictionary of options with highlighting, I've implemented a function in my BeautyPrint module. This function returns a string, which is then passed to the display variable and then printed. For the interactive aspect, we import the keyboard module. Within the class, a function is defined to modify active options based on user input. This involves capturing key presses, determining column and row counts, mapping the first value in the active options list to X and Y, and identifying the name of the selected option. Key presses dictate movement within the options grid. For instance, pressing up decreases the Y value of the active options, but it is ensured that it remains within the bounds of the number of choices using a modulus operator. The similar logic applies to down, left, and right key presses. We want the program to listen to keyboard inputs until the user presses something, so we set another variable, is listening, and enclose all of this in a while loop. If is listening is false, the loop is terminated. Back in the listen function, we set is listening to false and return the selected choice when a specific condition is met, such as the user pressing the spacebar button. Upon exiting the loop, conditional operations can be done based on the selected choice. This can be used to redirect the user to another function. To enable users to return to the previous scene, we introduce a variable named chosenOption. This variable stores the previous function that initiated the current scene. We then modify the listen function to execute the chosenOption variable upon hitting the backspace key. This triggers a return to the previous scene. In the current scene, the same process is implemented. Is listening is set to true, followed by a loop to capture key presses. The actual code delves into finer details as it contains more variables. The principle remains the same.
And that was Hermes, our reading speed program, where you can track your progress and even enhance your reading skills. Our goal was to ensure a smooth and personalized user experience for all, as shown by our quality of life features, such as the adjustable terminal window colors, the font sizes, but most importantly was a variety of source options ranging from the local files to custom internet query options. Once again, we appreciate the opportunity to showcase our project, and thank you.